In this video, we are going to learn about Gnutella. Okay, so Gnutella is a decentralized peer-to-peer file sharing network protocol. Okay, so in this video, we are going to learn like how a peer can connect to Gnutella, and then how like the peer can actually any of the client can actually read or get a file in Gnutella cluster. Okay, cool. So the basic idea is we don't want a centralized server. Okay. We want a distributed servers. Okay. Which is not centralized. Okay. So eliminate centralized server, peers form an overlay network. Okay. Now the problem statement is like how do peers search or fetch themselves. Okay, so what happens that if a pair wants to search a file or something or fetch themselves, okay, so what they do, they bloat the whole network. Okay, so for example, so let's take an example. Let's say you want to search a movie. Okay, now you searched for a movie from this peer. Okay, and you want to know where does this movie exist. So what happens that this peer basically over like sends the message to to all the peers that it is connected to. Okay, now once this guy receives this like this RPC or HTTP whatever, okay, so this guy will also send it to everywhere. Again, when this guy receives it, okay, this guy will also send it to everywhere. Okay, now let's say this guy has the data, so he will send back that okay, I have the data. We will understand this little bit after. Okay, so first question is like how do a peer actually joins a Gnutella network. Okay, how does someone joins? So for joining, how first question is like if this peer wants to join this whole network, how can he know get the IP address or like host name to connect to any of this peer? Okay, so there need to be a bootstrap server, okay, which have a list of server by which this peer can connect. Okay, so this guy will go to that bootstrap server. Okay, he will provide IP, a list of IP, okay, a list of IP of some of the servers which this guy can go and join. So let's say in that list there is a server, okay, which is offline. Okay, this is offline. Okay, and there are list of servers which are online. So what will happen, it tries to go to this but it is unable to connect. Okay, no problem. Then it tries to go to it and it was able to connect. Okay, then again it was trying to go to it and it was able to connect. Cool. Now when this peer tries to go to some of the other peers which are already in the net cluster, okay, it will go with the TTL. Okay, time to uh, like time to connect. Okay, so in this TTL it will mention like you can only send the request to like two other people or two other clusters. Okay, so when this guy, so this sends the request to this server. Okay, so this sending the request is called ping. Okay, so it sends a ping request with a TTL, let's say of 2. Okay, so this guy will send it to its nearest neighbor, let's say this guy and this guy, and this guy sends it to nearest neighbor, one is this and this. Okay, so this guy already have one ping from this peer, so he will ignore this. Okay, and this guy will send to this and this. Okay, so they will so now when this guy sends over here, right, the it becomes 1. Okay, and when it receives, it sees that I have only like the TTL is only 1, so I won't send it further. Okay, so then this guy will respond with a pong. Okay, this guy will respond with a pong. This guy will also respond with a pong. Okay, so here, and this guy will also respond with a pong. Wherever it was going, I don't know. This guy will respond with a pong. Okay, and at the end in the pong, they will also send their IPs. Okay, they will also send their IPs. So finally, this peer got connected to this guy, this guy, and this guy. Okay, with and all of them have the Pong reply in which they have sent their IPs. Okay, so now this guy is also part of the cluster, and this guy will refresh, like send the ping request to all this guy periodically in some intervals, so that it can keep maintaining a connection with all these servers. Okay, now why did we had this TTL? The reason why we had this TTL, so that this ping request doesn't goes to the whole cluster. Let's say there in this cluster there are 1 million peers. Okay, if I'm sending this ping request to 1 million peers, the network will unnecessarily get bloated and it will take huge amount of like resources, right? And obviously it cannot connect to 1 million of peers at a time, right? So we send it with a TTL, and if like I am able to even connect with one of the server, I can actually manage to connect with another servers, or I can say another peers. Okay, and it's good to go. Cool. Now the second problem is, let's say I'm trying to search for a song. Okay, I'm trying to search for a song. How can I search it in this architecture? So let's say this client want to search for a song. Okay, a.mp3. Okay, now he sends this to this peer. Okay, so this peer sends a sends an RPC to this two guy. Okay, so when I say RPC, actually I'm saying wrong. So the whole algorithm actually works on top of HTTP. So this guy sends an HTTP query to these two guys. They don't have it. Okay, so when it sends also, right, here also there will be a TTL. Okay, so let's say it will send with TTL 3 again. Okay, now they didn't have, so they also send it further. Okay, so they send it further, and the TTL over here become 2. They also didn't had it. Okay, so they send it further, and here the TTL become 1. Okay, this guy also didn't had sad life. Okay, so none of them responds back. Okay, now when it sent over here, this guy sent it, this guy sent to two places, right, here and here. Here also there was one, and this guy had that a.mp3. So what it will do, it will send a, so when the query is sent, this guy also sends its own IP. Okay, IP and TTL. So when this guy have it, okay, what he will do, he will directly send an HTTP to this guy with its own IP. Okay, why is it is sending the HTTP with its own IP? So that now these two people can connect with each other and transfer the data. Okay, now they can connect with each other and transfer the data. Okay, so so basically, if this guy want to receive a.mp3, he doesn't have to like go through this all this path and then get a.mp3. Like it shouldn't happen that this guy is sending here, then here, then here. They will directly like communicate with each other and get a.mp3. Cool. Now, what are the pros and cons of this whole P2P connection? First pro is that there is no network, no centralized server. Okay, there is no master, there is nothing like that. Okay, so fully distributed. Okay, and the second thing is, even if one server goes down, it's not a problem, because like we have seen, like each server actually sends, each server or like each peer sends the connection to multiple people. So even if this guy goes down and this was like connected with both of them, no problem, it can go directly from here to here, correct? But the cons are that the whole network get flooded with all this ping or all these queries. Okay, and searches are sometimes unreliable. Let me give an example of that. So let's say a.mp3 was here. Okay, a.mp3 was here. Okay, here we searched for a.mp3. Okay, and the TTL was 3. Okay, so it sent over here. So it was 3, 3. Then it came here 2, 2, 2, 2. Okay, then it went here 1, 1. Okay, then it came here 0, 0. So maximum where you can reach is still here. But the a.mp3 file was just one hop after that. But this guy actually gets the response that a.mp3 doesn't exist in this whole cluster, so it doesn't exist. So search is unreliable. Okay, And third, last but not least, I don't know how much this is important, but there is like no mechanism for freeloader. Okay, so it may happen this guy only consumes and downloads the data. This guy never serves any data. Okay, he's just someone who is downloading the data. So there is, and they don't want to promote that. Like, if you want to be in this cluster, you have to give some data also and takes, and then only you can take some data. There is no way of handling those kind of things. Okay, so this is like basic architect theory about Gnutella P2P connection. Okay, thank you.